we're going to use these Lewis symbols to help us model bonding in molecules. Okay, the last unit we talked a lot about ionic compounds and how you can, knowing the number of valence electrons, you can predict the types of cations and anions, the charges on the cations and anions, and then you can predict the formula of the ionic compound. With the covalent compounds, you can't do that. In order to know the formula, you have to know the name. For example, carbon dioxide tells me that there's 2 oxygens. But beyond that, we need to know what's bound to what kinds of bonds exist in those molecules. And to answer that question, we have to go to the next level here, and we have to figure out about the bonding. And the reason why the covalent compounds are more complicated than the ionic compounds is that the ionic compounds just form crystals. It's cation surrounded by anion, surrounded by cation, surrounded by anion. It's these crystals. So if you look, for example, at calcium carbonate or sodium chloride or magnesium chloride, this like baking soda and table salt versus Epsom salts, basically, they're all white little crystalline substances, and some may look more powdery than others depending on how much they've been ground up. But nevertheless, they look very similar because they are similar in structure. That's why they have similar properties. They're solids at room temperature and pressure. They're normally just white in color and that sort of a thing. Whereas the covalent compounds have all kinds of varying, they can exist as gases, liquids, or solids, varying colors, all kinds of varying properties with molecules, covalent compounds. So remember, the covalent compounds, here's a nice modern model of a hydrogen atom and a hydrogen atom. Remember, all those dots doesn't mean that there's a whole bunch of electrons. That's just a shaded region telling us, the more shaded in is the more likely where you're going to find a particular electron. It's a probability plot is what it is. Okay, and so you have the 2 separate hydrogen atoms. As the 2 atoms get closer together in space, like for example here, the electrons are more likely to be found between the 2 nuclei than outside the 2 nuclei. So this is the beginning of the formation of a covalent bond. And then once the 2 atoms come together, then when to form a covalent bond, then the probability exists that those 2 electrons are going to be found between those 2 electrons. We talked about this in the last unit. I tell you this again because in order to understand now, to expand to covalent compounds and understand them a little bit better, we need to remember that a covalent compound is when atoms stick together by sharing electrons. Okay, sharing electrons. So the atoms are drawn together. So there's remember, an attraction for the electrons of one atom by the other nucleus, attraction of electron from this atom by this nucleus. And so together, these 2 nuclei are holding the electrons between the 2 of them. And we call that a covalent bond. All right.